Okay, so chapter 9 is about quadratic functions, and truth be told, this is one of the more challenging chapters. Quadratic functions, very similar to linear functions, but linear functions were a line, and quadratic functions are not a line. Quadratic functions are always in this form, or they could be rewritten in this form. So it's y equals a x squared plus bx plus c. You'll notice I have this x squared underlined. That's really how you know it's a quadratic. It's got an x squared term. So this is the standard form. This number can't be a 0. If the a were a 0, that would get rid of the x squared term. And if you just had y equals bx plus c, well, that's going to be linear. That should look really familiar because that's the linear for this. So you must have this x squared to be a quadratic. Also, in a quadratic, this is the only thing that is allowed to be a squared term. So you shouldn't have like a y squared. You're only going to have an x squared. So that's the standard form. The first types of questions they're going to ask you in section 9.1 is just, is it a quadratic? So they're going to give you things like y equals x squared plus 3. And they're going to say, is that a quadratic? And you would say, yes, it's a quadratic because I could rewrite this to look just like that. If I really wanted to, it would be y equals 1 x squared plus 0x plus 3. So you're allowed to have this thing be a 0. Your b term could be a 0. You just have to have this x squared. They're also going to give you tables. And when they give you these tables, you had tables like this in chapter 5 as well, when they were asking about linear functions. And these x values always had to go up by a constant term, and the y's had to also increase by some constant term, and that's how you knew it was linear. Well, in this term, there's something called the second difference. And here's what I mean. When you have a quadratic function and you put the values in a table like this, these x values are going to increase by some constant term. So from here to here, I'm going up 2. That's a plus 2. From here to here is plus 2. Plus 2, plus 2. So these are increasing by some constant. With your y's, from here to here, this is a -6. This is a -2. This is a +2. This is a +6. So you'll notice that this is our first difference, and the first difference isn't constant. If it were constant, that would make this linear. With quadratic, it's something called the second difference that's constant. So essentially you do what we did here, you just do it again. So from -6 to -2, I increased 4. From -2 to +2, I increased 4. From 2 to 6, I increased 4. So these have a constant second difference. So it's the difference of the difference. That is what makes this table quadratic. All quadratic functions, when you graph them, they make a parabola. So a parabola looks like this. This is a parabola. And all of your quadratic functions are going to be some variation of this. If a quadratic function looks like this, so the parabola is going upward, that means this a value is greater than 0. So essentially, if it's like this, a is a positive number. And I always think like if a is positive, then it's a smiley face. If your parabola is upside down, say your parabola looks like this, that means this a value is a negative number. So a value is less than 0. And so a equals a negative number. And again, it's negative, so this is a frowny face. So if you have a parabola like this number is positive. If your parabola looks like this number is negative. If your parabola is a upward facing parabola, so a smiley face parabola, this value right here, called the vertex, would be a minimum. It's a minimum because it's the lowest point. So if you have an a value greater than 0, you have a minimum. If you have a parabola like this, it's the frowny face parabola, so you know your a value is negative, then your vertex is the maximum. It's the high point. You're asked to find the vertex in these, but the way they have you find it is truly just like they give you a graph and they just ask you to locate this point on a graph. So my hope is that you're okay doing that without me actually showing you graphs. We'll talk more about how to find it mathematically in the next section. When you have parabolas, they also ask you for domain and range. Domain, again, we talked about this when we learned about linear functions. Domain is always the x values. It's your right and left. Your domain is how far that way does it go, how far this way does it go. Your range is your y values. So it's how far up and down does it go. So if I were to, and I'll just kind of do like a really rough sketch here. Okay, so this is my parabola that I just drew. First of all, the vertex is your lowest point, and in this case, my vertex is the point 0, 1. And that's because it's side to side 0, up 1. So that's my vertex. Now, my domain, meaning the x values, this, even though it kind of appears like it might be stopping, this would actually go on forever. Forever and ever, this way. So this is going towards negative infinity. This is going to go forever and ever, really slowly, but it would still continue to get wider and wider infinitely. So you're going to say that your domain is all real values. All real numbers. Some teachers will have you write that as negative infinity, comma, infinity. That's the domain. Now, your range your range is the y values, or the up and down. So my range for this, my lowest point, this is my minimum, is a 1. My high point, it goes on forever. So because range is talking about y values, you can write this as y is greater than or equal to 1. That is my range. I'm saying that's the lowest point, and it's everything higher than that. So I'm going to give you another example of domain and range. So let's say I'll have my vertex right here. It's going to go that way and that way. So there's my very roughly drawn parabola. So in this, my vertex is 1, 2. Over 1, up 2. So vertex is the point 1, 2. Now, my domain. My domain is how far left and right it goes. It's those x values. With every parabola, it's really going to be all real numbers. It's going to be, because it's continuing, even though this is a terrible drawing, your parabolas will actually continue to go forever this way and forever this way, just very slowly. So your domain, again, is going to be all real numbers. Now your range. This particular picture, it has a maximum point. And my range is the y values. So in this case, it's the y values, but because this is a maximum point, it's all the y values less than or equal to 2. So that is what we mean when we say domain and range, maximum and minimum. If you were given a problem, this is just one more example problem. First of all, you know that's a quadratic equation because it's written in that standard form. It has an ax squared plus a bx plus a c. The a value is 2. So this is a parabola that is facing upward. You know this is a parabola that's facing upward because this a value is positive. So it's a smiley face for a positive a value. Also, you know it has a minimum because any parabola that is shaped upwards is going to have a low point or a minimum. So those are kinds of questions you could be asked, where they might just give you a function, and even without actually knowing how to graph this function, by just looking at this number in front, you can tell which way it's facing and if it has a maximum or a minimum. And that is pretty much it for section 1.